day everyone, my name is Cherry and Flores Rao. So for today's video, I am going to tackle about how does microclimate modification affects plants and livestock. Before I'm going to proceed, let us give a brief discussion about microclimate modification. So what is microclimate modification? Definition of microclimate is an attempt to change or control the elements of climate in a microscale. The climate is appropriate to conditions suitable for the growth of plants. In fact, all modification of climate-based products can be done with the approach of changing the heat budget or its components. Why microclimate modification is important? To increase heat dissipation of plants by replacing humid air by dry air in the intercellular aspects. Shelter belt produces wind speed. It is useful for betterment of the microclimate of field, thus in increasing production and productivity. How does microclimate modification affect plants? Microclimate modification can have significant effects on plants, as it directly influences the environmental conditions in which they grow. Here are some ways in which microclimate modification can affect plants. Temperature. Altering the microclimate can impact temperature levels. For example, creating shade or using mulch can lower soil and air temperatures, which can be beneficial during hot weather or in regions with extreme heat. Conversely, adding reflective surface or windbreaks can increase temperatures, which might benefit plants in cooler climates or during cold snaps. Humidity. Microclimate adjustment can affect humidity levels. For instance, using irrigation or mulching can increase local humidity, which can be advantageous for plants that prefer higher moisture levels. Conversely, reducing humidity through improved ventilation or spacing can benefit plants that are susceptible to fungal diseases and humid conditions. Light. Manipulating microclimate can impact light availability. Shading can improve light-sensitive plants from excessive sun exposure, while reflective surface can redirect light to areas that receive less natural light, aiding the growth of shade-loving plants. Wind. Wind speed and direction play a role in microclimates. Windbreak can shield plants from strong winds, preventing wind damage and water loss through transpiration. On the other hand, strategical place opening can encourage air circulation, which can reduce the risk of disease in humid conditions. Precipitation. Microclimate adjustment can influence the distribution of rainfall or irrigation. Rain gardens and swales can help retain and distribute water to plants in regions with low precipitation. Conversely, drainage system can prevent waterlogged soils in areas with excessive rainfall. Soil conditions. Changes in microclimate can indirectly impact soil conditions. For instance, temperature and moisture levels affect soil temperature and moisture content, which in turn affect roots development and nutrients availability. Pest and disease management. Microclimate modification can influence the presence of pests and diseases. Adjustment like the use of netting or row covers can protect plants from insect infestations, while improved air circulation can reduce the risk of fungal diseases. In summary, microclimate modification can be a valuable tool for gardeners and growers to optimize growing conditions for plants by adjusting temperature, humidity, light, wind, precipitation, and other factors. They can create more favorable conditions, ultimately promoting healthier and more productive plant growth. Temperature regulations. Adjusting the microclimate can help regulate temperature in animal housing facilities. Heating or cooling system can be used to maintain suitable temperatures for different livestock species, ensuring they are neither too hot nor too cold. Ventilations. Proper ventilation is crucial in livestock facilities to remove excess moisture, odors, and airborne contaminants. Adequate airflow can improve air quality, reduce the risk of respiratory diseases, and enhance animal comfort. Humidity control. Microclimate modification can control humidity levels in livestock environments. Excessive humidity can lead to respiratory issues and promote the growth of pathogens, while too dry air can cause discomfort and affects animal health. Humidification or dehumidification system can help maintain optimal humidity levels. Lighting. Lighting plays a role in the microclimate of indoor livestock facilities. Providing appropriate lighting conditions, such as natural or artificial light, can influence animal behavior, reproduction, and overall performance. Pest and disease management. Microclimate modification can impact the presence of pests and diseases in livestock housing. Proper installation and sealing can help prevent the entry of pests, and temperature control can deter the growth of disease-causing pathogens. Water supply. Maintaining access to clean and uncontaminated water is vital for livestock. Microclimate adjustment can include designing water supply systems that prevent freezing in cold weather or excessive heat in hot climate. Feed storage. Proper microclimate management in feed storage areas is essential to prevent spoilage and maintain feed quality, ensuring that livestock receive adequate nutrition. In summary, microclimate modification in livestock management is essential for